Okay, fine. Okay, you look at your KSP itself. We have zinc, ZnS, and then this one, right? So which means that you're supposed to calculate the ionic product of Zn2 plus times S2 minus as well as Cu2 plus and S2 minus, right? Based on the KSP, right? Okay. So based on this one here, your zinc 2 plus here is what? 0.1 mole per dm cube. Your S2 minus is 10 power minus 35. And it is the same value as the copper. Then you compare the IP individually with the respective KSP. That's all. Okay. So in this question here, why don't we need to recalculate the concentration? Because we're not given a volume. They never mention anything about volume, right? So therefore we have to make an assumption, assuming that whatever value they give us here is already the resultant concentration, right? Okay. By right, we should calculate resultant concentration, but they didn't give us the volume over here. Okay, so you compare each one respectively to their KSP, and then based on the scenario given, you can predict whether you got PPT or not. Is it okay?
Why do you not have to calculate the amount of PPT and reduction in your S2 minus, then recalculate for Zn?
They didn't give the volume. We cannot assume that they have equal volume, right? Since they didn't give us volume, I can only assume that whatever the value they give us in the questions here is already the mixture concentration.
No, as in like what's it called? Cu2 plus CuS will precipitate out, right? That'll lead to your concentration. Oh, it'll lead to concentration decrease. I think too much.
It's okay.
For S2 minus, it's the same concentration for Cu2 plus because for zinc and copper because it's 1:1. Yeah, that was where.
Okay, then that's it. Okay, ma? Okay, let's do a structured question. Can you refer back to your structured questions? Question 2. Okay, question 2. This time round, I'll let you do on your own. We did MCQ just now, question 5. So now we are at question 3, structured question. And then go into the expression. Can you see the expression? The expression itself. Okay, let's do with part C now. How many underline equal volumes? Okay, now they give us volume already, so we have to calculate our resultant concentration from the flooded lead workings and whatever potassium iodide are mixed, right? Can Lashita tell me what are the two ions we need to calculate the resultant concentration?
The common ion PB.
This is a predicting precipitation one, all right? I want you to tell me what is the KSP of the salt given. What salt of the KSP is given?
Ki.
What is the KSP given?
Is the 4 times 10
No, they will tell KSP of what is given, right? So, of course, we calculate from above the KSP of lead-2 iodide. So, therefore, the concentration of the ions you need to calculate is lead-2 plus and iodide. Just like I got stress, right? Like so many ions, how do I know which are the 2 ions you need to calculate the concentration? So based on the KSP, you all better write down. Look at what is KSP given. So we calculate Pb2 plus. Okay, we calculate I minus resultant concentration.
So it's on based on the OG.
Based on the KSP. Right, based on whatever KSP they give it to you. Okay. Now in this case here, we have the iodide itself, which is 4 times 10 power minus 3, right? But because equal volume, I know the resultant concentration. Very good. Good job, John. Will be half. Underline, circle, highlight. Huh?
I'm just times 2 again.
No. Because the each other is Ki. Okay. Now the unknown now is the Pb2 plus, right? Okay. So we let the concentration of Pb2 plus, okay, be represented by X in the flooded water, right? But the resultant one will be x divided by 2. Now we sub into our KSP expression. Okay, now KSP is given, right? So 3.9, not given as in we already calculated out, right? So x over 2, then we have 2 times 10 power minus 3 power 2. Now you solve your x. That's it. Got it? Let the question flood in now. Come. It's okay. I think people have different strength. Like you ask me, my strength is in organic. Yeah. Calculation still okay. Yeah.
How do I do again? Oh, I never
Come. I understand you. Tonya, you want to ask me anything? Come. Let the question flood me. See where this flooded water.
I either did something wrong or the calculation wrong.
The banana was previously found, right? Then here, the B part 3, right? It was found previously. Okay, let me just show you the answer there so that we can all have some break, okay? So, like what I mentioned, right, we already conclude the common ion type of questions here. So, y, 2y plus 0.1, then we do the assumption, right? Then we start into our expression, then equate to the calculated KSP in your B part 3, right? Then we solve, okay? And then, of course, the question say account for the difference. So that's where this question a bit greedy. Not only they want you to prove the common ion effect by the calculation, they also want you to explain, right? So that's why I have the 2 times proving. Proved by calculations, right? As well as Song Yong, proved by the explanation. Okay? That's all. Okay, so as usual, I will only upload this once I finish with the subject class. Probably by Saturday evening, I can upload this already. Okay, yeah. The AlphaGo answer already uploaded to the WhatsApp group chat now, so you can see. Okay, we take a short break. Zoom recording. Okay, now remember this is question 2A, right? Then this is 2B, right? 2C is the tougher one, so I'll skip this one first because it involves calculation. All of us should welcome 2D and 2E, the 4th and the 5th one, because it's LCP again. All right, so once we finish this one, I'll give you some homework to do, and then that's it already. Okay, only MCQ only, right? Okay, now question type 2D. Let me zoom. Okay, I explain this one, then you think down. Okay, so this is strictly by LCP, right? Now, when we have common ion effect, solubility drop. This is the direct opposite. When we have complex ion formation, we will always increase the solubility. So that is a fact. All right. So for what do I mean by complex ion? Okay, shall I just cover this one first? Then you all take down first, okay? Because if I show everything, you all will not listen to me. Complex ion formation, you all have seen before. Say out the title first. Complex ion formation, you will always cause the solubility of a salt to increase. So direct opposite as compared to common ion effect. Okay? Can? Okay, can I have Lashita give me an example of a complex formula?
Please. SO4.
Okay, can I recall for you? Periodicity. In the chapter called periodicity, we come across complex formula, right? You come across complex, right? Periodicity. Or someone can help me out here? Periodicity, all of you had taught you already, right? Periodicity, can I have John? I never teach you. Your school teach you? Never. Matthew, you help me out here? Periodicity, we come across lots of formula. AL?
ALOH 5OH 2 plus.
Okay. ALOH4 minus, this is example of a complex. ALH2O.
Oh, H2O 5OH.
H2O, maybe 6, for example. 3 plus, this is also example of a complex. Okay?
I have the H2O.
Yeah, AlH2O5OH. 2 plus, this is also another example of a complex. So these are all the complex we've seen before in periodicity. Okay, yes, okay. So that is example of complex, right? So I'll give it another example. For example, okay, we have this is the original sparingly soluble salt, CuOH2. So dissociate partially, right? Okay. When we add your NH3, this complex will form. So when the complex is formed here, right, what happened will be it will cause the copper 2 plus concentration to drop. So when you drop the LCP equilibrium shifted forward and more of the copper 2 hydroxide can dissolve. That's all. Okay. Now this one over here, if you learn bio, this is actually the chemical formula for Benedict solution. Okay, we will soon learn these under the last chapter called transition method, where we learn more complex. It's definitely easier than polymer, trust me. The plastic one, trust me, really. Okay, I have never ever avoid a topic so much. That is polymer. It's come back to haunt me. I've avoided it for the past 6 years because I refused to take H1, but now no choice. Okay, so please take these down. This one here, by the way, just to let you know, bio student is Benedict, okay? But chemistry, we will soon learn this one under transition method, last chapter of your entire 23 chapter. Okay, take these down, okay? So if you ask me, do I need to memorize a formula? Not now, but later when we are at transition method, it's compulsory. Okay, for bio, of course you don't need to know the formula, right? Just know the blue color Benedict solution to test for reducing sugar. You do. Bio don't need. Bio don't need. Chemistry need to know how to prepare in situ on the spot. Bio, they just provide you, right, the blue color. Is it? Yeah.
We need to prepare.
We have to know how to prepare.
Yes.
I think.
Chemistry, yes. Chemistry, instead of calling this Benedict solution, they call it Tholen's reagent.
Oh, that's the one.
Tollen under carbonyl.
Oh, that's the one.
That's the one. We haven't learned carbonyl. Carbonyl is coming after I finish all the KSP, all the acid bases. Okay.